All right, in this video, what we're going to look at is graphing and recognizing inverses of relations and also functions. So for your focus, what you will be looking at is I will be able to graph an inverse of relations and functions. All right, so let's take a look. We can find and apply inverses to relations and functions, which is what we're going to do. And remember, let's do a reminder about what a relation is. Remember that that is just a set of ordered pairs, whereas your function is a relation which has one x value to one y value. And the way that we graph the inverse relation is actually nothing more than a reflection. We actually reflect each point across the line of y equals x. And if you think back to what you learned in geometry, when you reflected a point over y equals x, that was equivalent to just switching the x and y values. So if you started with a point of xy and you reflected it over that line y equals x, the new point became yx. So let's take a look. So here we have a relation over here at our table. So we have points 0, 2, 1, 5, 5, 6, and 8, 9. Okay, first thing we're going to do is we're going to actually graph those points. So let's do that real quick. And then we're going to connect them. So the 0, 2, the 1, 5, the 5, 6, and the 8, 9, and then we connect them. Now what we're going to do is we're going to graph the inverse. So to graph the inverse, that is nothing more than switching those x and y values. So we're going to make a new table with our switched values, and it's going to look like this. So our 0, 2 is now 2, 0. Okay? So what we did was we had that xy value. To take the inverse, we just switched them. The 1, 5 becomes the 5, 1, and 5, 6 is now 6, 5, and 8, 9 is now 9, 8. Now we're going to graph the line y equals x, because remember that line y equals x is our reflection line, and then we'll graph the inverse. So here's our line y equals x. I already see it there. There we go. And now we're going to graph those points. So we'll graph our 2, 0, 5, 1, 6, 5, 9, 8, and we're going to connect them. Now remember from geometry again, if y equals x is your line of reflection, then those points will be the same distance to that reflecting line. And if you look really close, you can see that these points are in fact the same distance to the line of reflection, which is that y equals x. So the next thing we want to look at now is look at the domain and the range. So we're going to start off with our original function. And let's look at the domain. So our original function, we started here at 0, and we went, how far did we go here? We went to, is that 8? We went to 8. So that is our domain. And our range, so our range went from, so we have to focus now on the y, we went from 2 all the way to 9. So let's write our domain. X is between 0 and 8, and our range, y, is between that 2 and 9. Now let's look at the domain and range of our inverse. Now remember, when we did that reflection, remember your xy, when you reflected it, we switched, and our reflection points became y equals x. Okay, now let's take a look at our our inverse, remember, which is the red. So we start here at 2 for our domain, and we go to, what is that, 9. Well, that's interesting. We started at 2 and went to 9. Does that look familiar? Look at what your range was on the original function. Now let's look at the new range of our function, our inverse. And let's see, we start here at 0 and we go up to 8, 0 to 8. Well, does that sound familiar? That was actually our original domain. So did you see what actually happened? Not only did our x and y coordinates switch, but so did the domain and range. Your new domain was actually the original range, and the new range was actually the original domain. Now I want you to think about that. That should make sense to you, because if you switch the x and the y, what is domain and what is range? They are x and y, right? So if you switch the x and y, your inverse will have as its new domain, it will have the range, and for its range, it will have the original domain, and that will work every single time. And that should make sense. Well, let's try another one. Okay, well, let's graph this relation and connect the points. Let's do that. So there we have points 1, 0, 3, 1, 4, 2, 5, 3, and 6, 5. Now what I would like for you to do is stop the video, or pause the video actually, and I want you to rewrite your table, but rewrite it as the inverse table. So you're going to rewrite it, all of your ordered pairs of x, y become y, x. And then I want you to graph that new, or the inverse relation on the coordinate plane. So pause your video and do that, and then turn it back on. All right, let's see what you got. When you switch the x and y values, your new table is now 0, 1, 1, 3, 2, 4, 3, 5, and 5, 6. Did you get that? So your graph now should look like this. Here is your line again of y equals x. And now the red is now your inverse. Is that what you got? And do the points look the same distance to the coordinate plane? I mean, to the reflection line of y equals x? Yes, they do. Now let's take a look at the domain and ranges. So let's start with our original relation. Let's go back and start with him. So here we start, for domain, we start at 1 and we go to 6. And then our range actually starts at 0 and goes to 5. So the domain goes from 1 to 6, and the range goes from 0 to 5. Can you guess? Can you take a good guess at what the domain and range is going to be of your inverse? Write it down, and then pause the video, write it down, and see if you're right. Okay, so let's take a look at our domain of our inverse. So actually we start at 0, we go to 5. Look at that. And for our range, we started at 1. Did we go to 6? Let's look. Yeah, we sure did. So again, what happened was our domain and ranges switched just like our x and y's. Now what I would like for you to do is this last one, I want you to do the same thing that we did on the two examples. I want you to graph the original relation, also connect the points, then graph the inverse. Go ahead and draw your line of y equals x so you can visualize that that is your line of reflection. Then identify the domain and range of each relation. I want you to bring this back to class so we can go over it together, and make sure that you also fill out your WISC.